So Avantika, any doubt in part 1 and part 2 of the differentiation basics?
No, sir.
See, basically I'll just take 2 minutes and try to explain what we have done in part 1 and part 2. And what do we plan to do in part 3? In part 3, basically the theory is not much, but we'll be doing lot of practice questions. So in lecture 1, basically what we studied was what is dy by dx. You know, the gist of 50 minutes of lecture was that dy by dx is basically it is a function which will give us the slope at any point of a curve. So what it implies is that, for example, uh, how does my physics life become easier is that if I have a function, say for example I have a displacement function which is a function of time and it is written as xt as t square. So this is my displacement function. So there is a body which is moving as per this function. So if I want to plot a graph of this function for positive values of t only, this is how the graph will look like. It is a parabola. Now what dy by dx does for me is that at any point of this parabola, if I want to find the velocity, all I need to do is just calculate the dy by dx of this function. Basically in this case I'll have to find the dx by dt of this function. The dx by dt would be my velocity function. Avantika, is it making sense?
Yes, sir.
So this is my displacement side. This is my time side. At times, see, one of the things which gets a bit confusing in calculus is the terminology which is used. At least initially when I used to find the terminology very confusing. So one thing that you need to understand is they'll write something like, say, y is fx. What this means is that y is a function of x. Now as we had discussed in our first lecture, one would be a dependent variable, other would be independent variable. So whatever is there on the x-axis is an independent variable, and whatever lies on this y-axis is a dependent variable. Are we clear about this?
Yeah.
So for example in this case, and that is why I was saying that the terminology becomes a bit easier. So for example, the example that I was taking of velocity, say displacement being a function of time, like this. So basically this means is that my t is my independent variable and this xt, that is my displacement, is my dependent variable. Is it making sense?
Yeah.
So if this is the curve and at any point of the curve, I can have the velocity. All I need to do is if somebody tells me how to calculate the differential of this function, that is, if somebody tells me how to calculate dx by dt, now dx by dt is basically calculating the differential of the function x. And what is x? X is xt square. So if somebody tells me how to calculate this d by dt of t square, I can find the slope of this function at any time that I want. Avantika, is it making sense?
Yeah.
Okay. And once I have if I have a formula, if somebody gives me a formula how to calculate this, if I get the velocity function, then I can also calculate the acceleration function, because I know that the acceleration function is given by dv by dt. Is it making sense?
Yeah.
So all I need to do is calculate the velocity function from the first step, then put the velocity function here, take another differential of it, and I will have the acceleration function also. Is it making sense?
Yeah.
So this is what we covered in lecture 1, the need of having a dy by dx. And then in the second lecture, what we did was we understood basically what we did was using first principles, using basic expansions. What we did was we took the easiest function, y is equal to x square. And then what we did was we found the differential of this dy by dx is equal to 2x. Now this is what we derived. If you understand what I'm saying, this is what we derived. Now these engineering students, these math students, they derive the differentials. They go through the whole process. They should know how to derive the differential of a function. But as medical students, I don't want to do the derivation, etc. Just give me the formula. So for example, the formula that we discussed last time was that if the function is x raised to power n, the differential of this function dy by dx would be given by n x raised to power n minus 1. Avantika, is it making sense?
Yeah.
Similarly, if the function is something like this, k xn, where k is a constant, then the differential is simple. All I need to do is just keep my k outside and take the differential of x raised to power n. X raised to power n differential is n x raised to power n minus 1. Avantika, is it making sense? Avantika, is it making sense?
Yeah.
So for example, let us take, just to clarify the matters, let us take an example. So for example, let us take displacement function as a function of time. It is given by x is equal to t cube. So I know that velocity is dx by dt. So if I calculate my dx by dt, velocity would be given by 3t square. Is it making sense, Avantika?
Yeah.
So if you see, now at any point of a displacement time curve, if I want to find the velocity, I can use this basic formula, v is equal to 3t square. So basically, I have the velocity function, the formula for velocity function, formula for the velocity function would look like 3t square. Is it making sense?
Yeah.
Now then, if somebody asks me what will be the acceleration at any time, then all I need to do is, because this is a constant, so 3 into the differential of this t square, the differential of t square would be 2t, and 2t into 3 would be 6t. So basically, using these two basic formulas, from displacement, I can calculate my velocity function as well as my acceleration function. Is it making sense?
Yeah.
So, this is what is powerful about calculus. That using if I have for example, in terms of motion, in chapter number 3, motion that we are doing, if I have the function of the motion of a particle, if I have the displacement function, then using my differentiation tools, I can calculate my velocity function as well as the acceleration function. Are we clear till here?
Yeah.
Okay. So basically, this is what we have discussed in detail. I think in more detail than is required. That is what we discussed in this part 1 and part 2. Are we clear till here?
Yeah.
Okay. So I'll just give you the gist of what we plan to do in this lecture. So what we'll want to do is that, see, the only function that we have, dealt till now is a simple function like x raised to power n, or rather another simple thing that we dealt was with k raised to power x, kx raised to power n. But these are not the only functions which we would incur in physics. There will be all kind of functions. Are we getting the sense of it?
Yeah.
So for example, just to give you an example, when these are the kind of functions that we will see in some way or the other once we start our doing the calculus based physics. So for example, this is the easiest function, constant function, fx is equal to k is a constant function. So this function would look something like this. So for example, y is equal to 5, just a constant. And if you have done the numerical homework, you would realize that dy by dx of a constant function is 0. Is it making sense?
Yeah.
Then this is what is called identity function, square function, x cube. So these functions are the spin of x raised to power n only. So these functions are pretty much simple. But then what we do is we start combining these functions. So I take two functions and I combine them. So for example, I take this function and this function, I make another function. Or what I can do is I can take all the functions and make a function like this. Avantika, is it making sense?
Yes.
So the point that I'm trying to make is that I can have again and again I will try to give you the application of all this in terms of physics, because that is what is important to us. So for example, I can give you a displacement function. I can give you a displacement function which looks something like this. So I'll give you a displacement function which looks like it is a function of time, so I should write time here. So I can give you a function like this: 5t cube minus 3t square plus t minus 5. I give you a displacement function like this, and then what I ask is, what is the acceleration? What is the acceleration at time t is equal to 5 seconds? Are you getting what I am asking?
Yeah.
So then you should know how to manage this kind of function, this function, which is actually a sum of this function, this function, this function, and this function. So you should know how to manage these kind of functions. Is it making sense? Avantika, is it making sense?
Yeah.
Okay. Then I can, rather than, see, what I'm trying to tell you is that we just have dealt with this basic function, x raised to power n.
Mm.
And then we did numericals. But then I can combine a lot of such functions and make a bit complex functions. So for example, this we can do because this is x raised to power half. This we can do because this is x raised to power 1 by 3. But then, let us say that we have a function like this. So for example, we have a log function. Or maybe we'll have a trigonometric function, a sine function or a cos function. And then another problem that we are facing is we can have a mix of the functions also. Am I making sense or not?
Yes, sir.
So for example, what I'm trying to tell you is that I can have my displacement given as sine t. I can say that my particle moves using this function. Is it making sense? Then I can ask you the velocity function and the acceleration function. Nobody stops me. Nobody stops the particle having any kind of function. So for example, your particle that you are tracking can have a displacement function given by something called let us say log t. Then to calculate my velocity function, I should know how to differentiate log t. Is it making sense?
Yeah.
So I should know the differential of log t. Is it making sense? I can have a particle which is moving using this function, so it can have xt is equal to e raised to power t. So I should know the differential of e raised to power t. Is it making sense?
Yeah.
So the challenge that I am facing is, if you are with me, the challenge that you are facing is, one is you should know the differential of functions like exponential functions, trigonometric functions, logarithmic functions. This is the first challenge that you are facing. The second challenge that you are facing is that you can make mixtures of different functions. So for example, you can make a function like say sin x plus minus x, sin x plus x, or sin x minus x. You can make a function like sin x upon log x. You can make a function like x into sin x. Is it making sense?
Yeah.
So the first challenge is to find the differential of so for example, let us take this example. So for example, one of my challenge now becomes is, one is how to find the differential of this function or the differential of this function. My second challenge is, if they come together like this, how do I find the differential of this? Is it making sense?
Yes.
Now again, something about the terminology. I'll spend just 2 minutes on the terminology. See the functions. So for example, this function sin x can be written as fx, because the terminology gets confusing here. So don't worry much about the terminology. As time goes, you'll get a hang of it. So fx is equal to sin x can be written what you can say is function of x is equal to sin x. This can also be written, they might also say that this is u. Now whenever they in calculus they use words like u, v, w, basically u, v, w's are functions. Am I making sense?
Yes.
Rather than saying fx, they might also use gx or hx. All this means is that they are just functions. It is as simple as that. Am I making sense?
Yeah.
So when they say this u and v, it is a standard notation in calculus that u and v are basically functions. So when it is written like this, u upon v, basically what they are saying is that you have to take the differential of let us say sin x upon x. Is it making sense?
Yeah.
So they might say find the d by dx of u into v. What they are saying is find the differential of product of functions. Is it making sense?
Yeah.
So let us solve the first our first problem first. The first problem is the solution to the first problem is pretty simple, and this is what is the solution. The solution is that we won't be using first principles to understand all this. So if the first rule that we have is that x raised to power n is nx n minus 1, this is what we have understood. The second rule is k into x raised to power n is k, this is that we have done in the last lecture. These two we have already done. Any problem in these two formulas?
No, sir.
Okay. Then these 6 plus 3, 9 differentials, we should remember and we should accept without any proof. Is it making sense?
Yeah.
So for example, a 11th class non-medical student will calculate the differential of sin x, and then he will calculate using the first principles, and then he'll come to the conclusion that the differential of sin x is cos x. Is it making sense?
Yeah.
Avantika, is it making sense?
Yeah.
But you just accept this, that the differential of sin x is cos x, differential of cos x is minus sin x, of tan x is secant square x, of cot x is minus cosecant square x, of secant x is secant x cot x, cosecant x is minus cosecant x cot x, and differential of log x is 1 by x, differential of ex is ex, differential of ax is ax log a. Is it making sense?
Yeah.
Okay. So this is the this is the first problem that we were facing, and the solution that we have been given is कि boss ये table है, इस table को देखिए, and these are the standard results, just cram these. Are we okay?
Yeah.
Okay. So for example, I'll just give you a small example and you'll understand what I'm saying. So for example, one of the rule that we are given is that if you are given, if you have to find the differential of a function like this, that dy by dx, where y is a sum of two functions, then all that you need to do is, now we are coming to the second problem, all that you need to do is find the differential of the first function plus find the differential of the second function. As simple as that. Avantika, is it making sense?
Yeah.
What does this mean to us? This means to us is that if I am given a displacement function, which looks something like this, that xt is equal to sine t plus let us say log t. If this is my displacement function of a body is moving using this kind of function. So if I have to find the velocity function, my velocity function would be given by the differential of sine t. The differential of sine t, if I look at the table, differential of sine x is cos x. So differential of sine t would be cos t plus differential of log t. What is the differential of log x? The differential of log x is 1 by x, so this will be 1 upon t. Avantika, is it making sense?
Yeah.
The same function, the same rule can be extended to minus also. So if there is a minus, then same rule is applicable. Is it making sense?
Yeah.
Okay. Now, so what is the simple application of the first rule that I have learned? The simple application is that let us say I am given a function like this, x raised to power 4 by 3 plus ex minus sin x. Can you see the PDF?
Yes, sir.
So for example, I have to find the differential of this. So what I know is that if I am given a function which is a sum of say 1 or 2 or 3 or 4 function, it doesn't matter. All I need to do is I need to find the sum or differences of all the functions taken independently. Just 1 second, Avantika, 1 second. So if I'm given any function which is a sum or subtraction of any given functions, all I need to find is the differentials of the functions independently and add or subtract as per the sign given. Avantika, any doubt?
No.
Okay. So let us take an example. So for example, the question which was given was y is equal to x raised to power 4 by 3 plus ex minus sin x. So what I'm trying to convey, Avantika, is that this is my u, this is my v, and this is my w, and I don't need to worry much because I just want to find the differential of x raised to power 4 by 3 I will find this independently, whatever may be the answer. I will find the differential of Ex independently, whatever might be the answer, and I will find the differential of d by dx of sin x independently, whatever may be the answer. Is it making sense?
Yes, sir.
And once I have found the differentials, I can write the answer, that whatever is my dy by dx, I can write the let me call this A, let me call this B, let me call this C. So dy by dx would be equal to A plus B minus C. Is it making sense, Avantika?
Yeah.
Now, my only problem now is, पानी डाल के साफ कर दे उसको. My only problem, वो tissue paper like. The only problem now is that do I have the rule for finding the differential of this, Avantika?
Yeah.
Yes, I have, because what I've been told is that whenever you see a function like this, that d by dx of x raised to power n, all you need to do is you need to write an n multiplied by n minus 1. Is it making sense?
Yeah.
Now, do I know the differential of d by dx of ex? I don't know yet, but what I've been told is that whenever you see a function like this, d raised to power ex, you can refer to this table, and the differential of ex is actually equal to ex. Is it making sense?
Yeah.
टिश्यू ले लो बेटा, पानी उसमें डाल दो. So d by dx of ex is actually equal to ex only. Avantika, is it making sense?
Yeah.
And I have to find the differential of d by dx of sin x. So again I look at the table, and I look at the differential tables, and the standard result that is told to me is the differential of sin x is cos x. Is it making sense, Avantika?
Yeah.
A word about terminology again. So y is written as fx. What this means is that y is a function of x. What this means is that this x is the independent variable and y is a dependent variable. Is it making sense?
Yeah.
The first differential of y, that is dy by dx, is called or written as f dash x. Is it making sense?
Yeah.
Then you can also take differential of this function, whatever may be this function, you can take another differential of this. Is it making sense? Amatika, is it making sense?
Yeah.
So for example, when we said that x is equal to t cube, and then we said that dx by dt is 3t square, I can take a differential of this function again. The differential of this function would be 6t, and in terms of terminology it is written as d square x by dt square. Is it making sense?
Yeah.
And this is also written like f double dash x. Is it making sense?
Yeah.
Another thing, I won't spend much time, but it will help you. When they say that y is a function of x, what they basically try to tell you is that x is the independent variable and y is the dependent variable. So for example, but they can, when they write that, because initially, as I've told you, this terminology is a bit confusing. When they write x is a function of t, all they are saying is that t is the independent function now and x is a dependent function. Is it making sense?
Yes.
And just to add to the confusion, I understand your confusion. Just to add to the confusion, they might say that this is actually equal to u. Is it making sense?
Yeah.
So the first rule that we have learnt is that the addition or subtraction of functions, to find the addition or subtraction of functions, all that we need to is just find the differential and add the respective differentials. So question 1, question number 2, question number 3, question number 4, question number 5, question number 6 are just addition and subtraction of differentials. Any doubt? Avantika, any doubt?
No.
श्रावणी जी, अब वहाँ बैठ गई फर्स्ट क्लास. आपको क्वाड्रेटिक और लीनियर में प्रॉब्लम है? हाँ, बैठो आराम से. शिवी कर्टन खोल दे यार, पूरा खोल दे. Okay. So now let us look at the second rule that is being given to us. The second rule that is given to us is that if there is a function which is a multiplication of two functions, if there is a function which is multiplication of two functions, how do you tackle that? You take the first function, you find the differential of the second function, then you take the differential of the first function and just multiply it by the second function. How it looks like? Let us take a simple example. So for example, let me take a very simple example. The same functions that we have dealt with now, they are easy to treat and you won't face any difficulty. So for example, I'm given a function like y is equal to e raised to power x into sin x. Have you understood?
Yeah.
Okay. So how do I find the differential of y? How do I find dy by dx? All I need to do is keep the first one waiting. Find the differential of the second function. Now, because I have already found the differential of the second function, I will keep the first function waiting. No, the second function waiting and I'll find the differential of the first function. भाई सीबी समझ आ रहा है? मिस्टर रुद्र, मिस्टर रुद्र,
हाँ
भाई सुन रहे हो? सो गए?
सुन
Avantika, any doubt till here?
No.
And see, finding the differential is not an issue for me because I can always look at the tables. That is not an issue. I can look at the table and find the differential of sin x. I can look at the table and find the differential of ex. And by experience, I know that the differential of sin x is by CB. और ex का differential क्या होता है बेटा? अरे वाह. अवंतिका, any doubt? Avantika, any doubt?
No.
Okay. So, when we look at these kind of questions, basically these kind of questions that you will have to do in the homework. Question number 2. You can leave this question number 3. This is a bit tricky, especially if you don't know how to deal with logs. This one is tricky. So, you can also leave 5th. But if I have a function like this, x5 into 10x, so how do I find the differential? So dy by dx would be given by, can you tell me one thing? What should be the answer? How should I find? Don't tell me the answer. How should I find? What would be the step number 1? Keep the first function waiting.
Yeah.
Find the differential of the second function. Then what should I do, Avantika? Mr. Rudra? Mr. CB? Because you have already taken the differential of the second function, now you will take the differential of the first function. The first function is x raised to power 5 and keep the second function waiting. Avantika, are we making sense or not?
Yeah.
So don't worry, these are simple questions. You won't face any difficulty. If you have done the homework, I had sent you a lecture that you needed to watch. Did you watch that lecture?
No, I'm not. No, I didn't watch the lecture.
ठीक है. तो बेटा अभी आप वॉच कर लीजिए, आपके पास कल का दिन है. So that is based on this lecture only. So there are a lot of practice questions done in that. I'll show you that lecture.
Yeah, that's and this is what you will discuss in next.
Yes. Mr. Rudra, कुछ समझ आया?
Yes.
Avantika, is it making sense now?
Yeah.
Okay, let us try to do this. Avantika, will you try?
No, I'll probably just watch a few.
Okay. Mr. Rudra को पकड़ते हैं, सो जाता है. Mr. Rudra बताइए.
So x cube
शाबाश.
differentiate
शाबाश.
log x.
शाबाश. बहुत बढ़िया. उसके बाद
फिर x cube को differentiate करेंगे.
शाबाश. Very nice. शाबाश. Very nice. उसके बाद जो दूसरा फंक्शन है that is written as it is. Why it is written as it is? Because you have already found the differential in the first term. Avantika, is it making sense?
Yeah.
Now I need the differential of log x. I don't know the differential of log x, so I look at in the table. So differential of log x, Avantika, is 1 upon x. So what should I write here? X cube as it is. What is the differential of log x, Avantika?
1 upon x.
Shabash. This would be 1 upon x plus, what would be the differential of x cube, Avantika? Mr. Rudra?
3x squared.
Shabash. Shabash. 3x square into log x. Avantika, is it making sense?
Yes.
So this would be x square plus 3x square log x. Avantika, any doubt?
No.
Yeah. So you take the first function. So for example, in the next question, this would be the first function. This would be the second function. This would be the first function. This would be the second function. So in question number 2, just do 2 questions. Any doubt till there?
No.
So this is the second formula that we use, and what I was suggesting was that what I was suggesting was that this is the lecture that you'll have to see. Do you see this lecture based on UV and U by V?
Yeah.
Do you see this?
Yeah.
So this is the lecture that is based on rule number 2 and 3. These are the tricky rules. The first one is simple. U plus minus V is simple. The tricky part is U by V and U into V. Is it making sense?
Yeah.
Mr. Rudra, समझ आ रहा है?
हाँ.
And see, this is again, if you directly want to jump on the numericals, you can look at this differentiation calculation examples for practice. But if you want to, have a general introduction again, then you can look at this. This is what I had recommended to you, this part B, introduction. But this will more or less cover the questions that I am discussing right now. Avantika, is it making sense?
Yeah.
So if you want, you can look at this lecture first, part B first, and then you can come to this lecture, this one, examples for practice.
Yeah.
If you are okay with the rules, if you have understood the rules, these UV rules, then you can directly jump to this one. So I'll send you the link of the both of these again. Are we okay? But
Yeah.
please use this 2-day break effectively. Are we okay?
Yes.
So if I have to find the differential of, so the first rule says if I have to find the differential of functions which are sum and addition and subtraction of various functions, and all I have to do is find the differential of the respective functions and add or subtract as per the sign of the original function. The second rule says that if two boys have gone to a barber shop, the first one would be get a haircut first, the second one will have to wait, and afterwards the second one will get the haircut and the first one will have to wait. Are we okay till here?
Yeah.
And this one, the third one, is a bit tricky. Let us look at this. This will take 5 minutes to understand. So what this says is, if there is a function which is written like u upon v, then how do we find the differential of y? We write a v square, then we write v du by dx minus u dv by dx. Let us try to understand this. So for example, if I have a function like say x upon log x, have you understood, Avantika?
Yeah.
How do we find the differential of dy by dx? Square of the denominator. Are we clear? Then write the denominator and find the differential of the numerator. Avantika, are we clear?
Yeah.
Then put a minus sign. I have already taken the differential of the numerator, so I will just write the numerator again and I will find the differential of the denominator. Avantika, is it making sense?
Yeah.
And of course, then I'll have to find the differential. Dx is 1 minus x. Log x differential is 1 by x whole divided by log x whole square. Are we clear till here?
Yeah.
Let us take another very simple example. Let us take another example. So I have a function y which is written as क्या बनाएं भाई? ex by sin x. Avantika, have you understood?
Yeah.
मिस्टर रुद्र बताइए कैसे करें? नीचे डिनोमिनेटर में क्या लिखो रुद्र?
sin x
साइन एक्स का होल स्क्वायर. फिर जिसका होल स्क्वायर लिया डिनोमिनेटर, आई राइट इट लाइक दिस. देन आई फाइंड द डिफरेंशियल ऑफ मिस्टर रुद्र द न्यूमरेटर. आर वी क्लियर?
yes
माइनस. अभी न्यूमरेटर का आपने डिफरेंशियल ले लिया है, तो न्यूमरेटर आप वेट करेगा और डिफरेंशियल किसका लिया जाएगा? डिनोमिनेटर का. सो आई फाइंड द डिफरेंशियल ऑफ the denominator and the numerator weights. Avantika, is it making sense?
Yeah.
So this would be sin x ex minus ex whole upon sin x ka whole square. Is it making sense?
Yeah.
So, Ms. Avantika, when we come to question 4th, this is what we will have to do. And you can skip question number 6. You can skip question number 5. This is a bit difficult. You can do rest of the questions. Avantika, any doubt? Ms. Avantika, any doubt?
No.
So, our homework would be question number 1 all parts, question number 2 first 4 parts, question number 4 first 4 parts. Would you be able to do these?
Yeah.
And as I have told you that if you have understood the rules, if you have understood the UV rules, then you can directly jump to these examples for practice based on UV. So this is a pretty detailed lecture. Or if you haven't understood, then you look at this introduction to differentiation rules, u plus minus v, u v, u upon v for physics example formula, class 11th. Any doubt, Avantika? Avantika, any doubt?
No.
Okay. So basically, as I told you in lecture number 1 only, that what is that we are driving at? Basically, we are driving at this lecture where we want to apply differentiation, the rules that we have understood in differentiation, to physics. Is it making sense?
Yeah.
Basically, we want to tackle of course, because we are doing chapter number 3, we want to do motion problems using calculus. Is it making sense?
Yeah.
Just give me 1 second. So, if we look at our textbook, the basic NCERT, our primary reference, if you look at chapter number 3, elements of calculus, differential calculus, do you see these graphs?
Yeah.
So if you remember, these are the kind of things that we have been discussing. If you see this x plus delta x, these are the kind of things that we have discussed in lecture number 2. And right now, in lecture number 3, these are the rules that we are discussing. Do you see these rules? Avantika, are you able to see these rules?
Yeah.
So these are the rules that we are discussing. And if you see, velocity is dx by dt, acceleration is dv by dt, d square x by dt square. This is where we are. And after having covered this, we'll have a We'll try to understand these basic rules of integration also. In the next 1 or 2 lectures, we'll be moving on to integration. We'll try to understand how does integration looks like, and how does integration help us. So, for example, in this textbook, when they talk about velocity being dx by dt, yeah, acceleration being dv by dt, this is the part of the chapter that we are covering. Avantika, is it making sense? We will do the numerical application also, but I just want to motivate you guys so that you know that this is whatever we are doing right now is part of our syllabus. So you shouldn't feel कि सर जंगल में पता नहीं कहाँ घुमा रहे हैं हमें, यहीं छोड़ देंगे. So if you see this formula, now it will make some sense to you at least. Or if we see this velocity formula, now it will make some sense. Avantika, are we clear?
Yeah.
So similarly, when we go to chapter number 4, before we go to chapter number 4, we'll have a discussion on vectors also. Now this part, the calculus part that we have covered, that v is equal to dx by dt and acceleration is dv by dt, it will come very heavily when we will be doing simple harmonic motion. There the functions that you will be using would be sine functions, cos functions. We'll have to know the differential of sine and cos functions. So I'll send you the scan of this. Please do these questions before you come for the Wednesday lecture. Avantika, are we clear?
Yeah.
And if you can, I would suggest that do these questions which are discussed in this lecture also. Are we clear?
Yeah.
Mr. Rudra, ho jayega?
Yes.
Okay, let's meet on Wednesday now. Yeah? Okay.